if hard water is treated with soap, what will happen? It forms a precipitate. After you boil, what you have to do? We have to filtrate that water. When you filtrate the water, you will get a soft water. When you add a zeolite to the hard water, exchange of ions takes place. It has got two structures. Okay, one it is in the gas phase and another one is in the solid phase. Hello everyone, I am Venu Prasad, Department of Chemistry, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. Today I am going to do session 2 of hydrogen. Okay, let us study today hard and soft water and its types, conversion of permanent hard water to soft water, preparation of hydrogen peroxide and its physical properties, shape of hydrogen peroxide molecule, chemical properties of hydrogen peroxide and its uses, physical properties of heavy water and its uses, dihydrogen as a fuel. Okay, now let us study hard and soft water and its types. Different types of hard waters are present, so which and all its types let us study. Okay, now let us study today hard water. Actually rainwater is almost pure. When it is flows on the surface, it dissolves many salts. Like bicarbonates, chlorides and sulfates, and it becomes hard water. Hard water forms precipitates with soap, and that is known as calcium and magnesium stearate. Usually water is purest form, but when it flows in the earth, what will happen? Here earth contains, in earth what and all is there? Different types of salts are there, different types of inorganic salts are present. Okay, like calcium, magnesium, iron and all is present. So when it is reacted with this such type of inorganic salts, it becomes hard water. Okay, but if hard water is treated with soap, what will happen? It forms a precipitate. So like calcium and magnesium stearate. Okay, next one, so it is not suitable for laundry. Hard water is not suitable for laundry. Means today if you are washing the clothes, if you are using a hard water, it is not suitable at all. Color will be gone in the clothes. So we should not use hard water for washing the clothes. Okay, there are two different types of hard water. That is, one is temporary hardness, another one is permanent hardness. Okay, now let us study temporary hardness. What do you mean by temporary hardness? It is a presence of calcium and magnesium bicarbonates. It is the presence of calcium and magnesium bicarbonate, and its causes for temporary hardness. Always if you have got temporary hardness means, then we should say that it's a presence of calcium and magnesium bicarbonate. Okay, and it can be removed. Here temporary hardness can be removed by, first thing is boiling. Just what you have to do, we have to take a hard water and it is boiled. Okay, when it is boiled, what will happen? It contains magnesium bicarbonate and calcium bicarbonate, and it is converted into insoluble magnesium hydroxide and calcium carbonate. Okay, temporary hardness contains which and all? Calcium and magnesium bicarbonates. Okay, when you are heating a temporary hardness of water, what will happen? Here magnesium hydroxide as well as calcium carbonate will be formed. Then these precipitates, and it can be removed by filtration. The filtrate is known as soft water. Okay, temporary hard water we have to take, that contains which and all? Magnesium and calcium bicarbonates. When you boil that water, what will happen? It has been converted into magnesium hydroxide and calcium carbonate. So after you boil, what you have to do? We have to filtrate that water. When you filtrate the water, you will get a soft water. Okay, this is a first method for removing the temporary hardness of water. Second thing is by Clark's method. Here temporary hard water is treated with lime. You can treat it with lime. It forms calcium carbonate and magnesium hydroxide as a precipitate. When you get a precipitate, what we have to do? We have to filter it. Okay, then you will get a soft water. That is by Clark's method. You are treating a temporary hardness water which contains calcium and magnesium. You are treating with which one? Lime. When you treat it with lime, you will get a soft water. Okay, this is one method for the removing of hardness of the water. Second thing is permanent hardness. Permanent hardness means it is due to calcium and magnesium chlorides and sulfates. Magnesium chloride and calcium chloride. Okay. So it is causes for permanent hardness. Okay. Here permanent hardness is due to the presence of calcium and magnesium chlorides or sulfates. We should know that. Okay. Next thing is conversion of permanent hard water to soft water. Now let us study this. Okay. Here hard water is treated with which one? Washing soda. When you treat a hard water with washing soda, what will happen? Here washing soda reacts with chlorides. Here it reacts with chlorides and sulfates of which one? Hard water. Calcium and magnesium, and it forms insoluble carbonates. It forms insoluble. It will be not soluble, just it will be insoluble carbonates, and it can be filtered off. Okay. Here now let us take here calcium chloride. Calcium chloride is treated with sodium carbonate. If you are treating calcium chloride with sodium carbonate, Na2CO3, what will happen? We will get calcium carbonate plus sodium chloride. This is the reaction. Okay. We have to take which one? Washing soda. Washing soda is treated with which one? Chlorides. Washing soda is treated with chlorides, and it forms calcium and magnesium forms insoluble carbonates. We will get insoluble carbonates. We got insoluble carbonates, and it can be filtered off. We have said that much only. We have to take one hard water. Hard water is treated with which one? Washing soda. That washing soda will react with which one? Chlorides. Chlorides and sulfates, and it forms insoluble carbonate. So I have got today carbonate. Okay. So when you get insoluble carbonate, what we have to do? We have to filter off. We have to filter it. Okay. Next thing is Chalcogen's method. Okay. Here second thing is sodium hexametaphosphate. Now let us take sodium hexametaphosphate is called chalcogens. Okay. And it is added to which one? Now let us add it to hot water or hard water. We can add this chemical to the hard water. What it forms? We'll get a complex ion which keeps calcium and magnesium ions in the solution. It will keep a calcium and magnesium ions in the solutions. Here Na6P6O18, that is known as which one? Sodium hexametaphosphate. And when it is treated with hard water, what will happen? You will get sodium ion. Sodium ion and sodium metaphosphate will get. Okay. We will get here 2 moles of sodium will be ionized. 4 moles of sodiums will be remaining. Okay. Then you have to treat it with which one? Hard water. Hard water is there. Then what you will get? You will get complex ion. When you get a complex ion, it contains calcium and magnesium. Next thing is conversion of hardness of water to soft water by ion exchange method. Ion exchange method. Now let us take one zeolite. Okay. Zeolite means hydrated aluminium silicate. Hydrated aluminium silicate is considered as zeolite. Okay. It is added to hard water. If you add a zeolite to the hard water, what will happen? Here exchange of reaction takes place. Exchange of ions takes place. Here you see NaZ. Okay. Aluminium silicate is treated, correct, right? Aluminium silicate is added to which one? Hard water. When you add a aluminium silicate to the hard water, here exchange of ions takes place. NaZ plus M2 plus will get MZ2 plus 2Na plus. Okay. Here zeolite is regenerated. It is regenerated by treating with aqueous solution of sodium chloride. So here you see zeolite is treated with which one? Sodium chloride. When it treated with sodium chloride, here exchange of ions reaction takes place, right? Exchange of ions took place. Which one? 2NaZ plus MCl2. Exchange of ions taken place. Here that is known as ion exchange method. Here exchange of ions takes place in the solution. Okay. Here first thing which one you have to take? First thing is zeolite. Where here zeolite is added to which one? Hard water. Here when you add a zeolite to the hard water, exchange of ions takes place. This is the answer. Okay. But zeolite is regenerated. Again, if you want to regenerate a zeolite, then what we have to do? We have to treat it with aqueous sodium chloride. Aqueous sodium chloride. Okay. Next thing is by synthetic resin method. We have to take now resins. Okay. Synthetic resin method means first thing is synthetic cation exchange. synthetic cation exchange containing organic with SO3H group. HSO3 group means sulfonic acid group, and it is converted into RNA, sulfonic acid, RSO3H. Okay, here it has been converted into which one? RNA by treating with sodium chloride. We will have sulfonic acid and it is converted into which one? RNA, means alkoxide, sodium salt of sulfonic acid. Okay, then what will happen? From which we have taken? We have taken with sodium chloride. Okay, and it is treated with hard water. The resin exchange takes place. Here you see RNA is treated with hard water. Here exchange of resins takes place. We will get sodium ion. Okay, again you have your regenerated. Here resins can be regenerated by adding aqueous sodium chloride. For resins, now you have to add little amount of sodium chloride. Again you can get purest form of resin. Okay, next thing is we have to take one note, small note is there. Here pure demineralized water is obtained by passing water through cation exchange and anion exchange, means mineral water and all we will get today in like distilleries and all. That is a purest form of water, correct, right? So how you will get that such type of waters? Just by mineralizing. Just we have to take ion exchange method, cation and anion exchange we have to do. Then we will get purest form of mineralized water. Okay, here you see RH means just we have to take, okay, and we have to take one resin, then you will get mineralized water. Okay, in this process exchange of calcium and magnesium ions or other cations is there. Okay, here exchange of which one? Calcium, magnesium and anions like sodium cations. Okay, here exchange of ions should take place. Okay, if you are treating with resins. Otherwise just we cannot filter it. We cannot take water which is we are getting a purest form of water, then we cannot filter it and we cannot make mineralized. Okay, so what we have to do? Just we have to take water which we are getting in the purest form, then we have to do ion exchange method by using some resins. Then what will happen? We will get purest form of mineralized water. Just we cannot filter it. If we are filtering that water, we will not get a purest form of mineralized water. Okay, so we are using ion exchange resins for the exchange of ions. Then we will get a particular minerals. Okay, so we will get a purest form of minerals. Then only we can get. Otherwise, it would be not a perfect technique for us today. Okay, so here exchange of ions we will take. And what will happen if you are getting a purest mineralized water means it is obtained by passing a water into the cation and anion exchange resins. So I have said that today we should use resins for the formation of purest form of mineralized water. Otherwise it is not successful. It is not successful by taking in filtration. We should not use that at all. By filtration we will not get a purest form of water. Okay, so in this process OH ions and exchange of Cl ions, HCO3, bicarbonate, sulfate and other anions. In this process liberation of OH ions and H plus ion takes place. These resins can be regenerated by treating with dilute acids and alkali. We should know this. Okay, here in this process exchange of ions takes place. Which and all? Here OH minus, Cl minus, bicarbonates and sulfates and some other anions. But here OH minus ion gets liberated, correct, right? It neutralizes H plus ion and OH minus ion gets neutralized. Okay, when you are treated with resins, and these resins can be regenerated when it is treated with alkali or some other acids. Okay, they have said like that. Okay, next thing is preparation of hydrogen peroxide. Now let us study the preparation of hydrogen peroxide. How? Just by acidified barium peroxide. Acidified barium peroxide is vaporized. Just we have to vaporize the barium peroxide and it is reduced pressure to give hydrogen peroxide. Just we have to take, what you have to do means barium peroxide we have to take. Acidified barium peroxide we have to take and it is treated with sulfuric acid. When you treat it with sulfuric acid, we will get a barium sulfate and hydrogen or water molecule and hydrogen peroxide. Here we need is only hydrogen peroxide. This is the major product. These two are minor product. This is a minor product and this is a major product. Why we say here major and minor? What we needed today, we needed hydrogen peroxide, not barium sulfate and water molecule. Okay, here just we have to take one barium peroxide and we have to evaporate it. For evaporation, directly it will not evaporate at room temperature. So what we have to do? We have to add little amount of sulfuric acid. If you add a sulfuric acid, what will happen? We will get hydrogen peroxide will be evaporated directly. Okay, next thing is form peroxide sulfate. Peroxide disulfate means just we have to hydrolyze it. Means peroxide disulfate means on hydrolysis. Just we have to do hydrolysis. If you are taking peroxide disulfide, for that if you are doing hydrolysis means then you will get hydrogen peroxide. Okay, this is the easiest preparation. Now let us take 2 alkyl anthracyl quinolones. Okay, 2 alkyl anthracyl quinolone we have to take and kept in an open environment in the presence of these two catalysts, lead or hydrogen as a catalyst here used, and here we have written O2 air they have said. So what will come to that? Just we should think that we have to keep this chemical in open environment in the presence of which catalyst? Hydrogen or palladium catalyst. Okay, we will get ethyl anthraquinoline, hydrogen peroxide and oxidized product we will get. Okay, this is one substituted hydrogen peroxide. Okay, this is one method. Just it is very easiest. Just we have to keep the chemical in open environment and we have to add little amount of catalyst. When you add a little amount of catalyst, we will get hydrogen peroxide as a product. Okay, next thing is physical properties of hydrogen peroxide. Now let us see how hydrogen peroxide is seen to us. Means in open environment if you keep, what will happen, or what is its color and what is its taste and all we can see. Okay, here it is a colorless liquid. It is a colorless liquid. Always hydrogen peroxide is a colorless and it will be like water only. Okay, and it is soluble in water. It is always soluble in water. But 30% aqueous solution of hydrogen peroxide is marketed as 100 volume of hydrogen peroxide. Means 30% hydrogen peroxide is taken in a small container and they have said that 100 volume of hydrogen peroxide. Just it will be 30% only. Okay, then we have to think that it is always soluble in water, they have said, correct, right? So they will take 70% of water and they will add 30% of hydrogen peroxide. Okay, 30 ml of hydrogen peroxide. So we can say that it is a 30%. Okay, if you are going to the medicals and all, we will get hydrogen peroxide as only 30%. Means they have mixed with water molecules. Okay, then because here 1 ml of 30% hydrogen peroxide gives 100 ml of oxygen at standard temperature. Okay, 3% of aqueous hydrogen peroxide is called as commercial market. We will get 2 types of chemicals, A grade chemicals as well as B grade chemicals in our chemical shops. Okay, so there are 2 types, commercial grade as well as analysis grade. Okay, so if you are taking commercially means we are getting only 3% aqueous hydrogen peroxide they have said. Aqueous means we should think that is mixed with water only. Okay, these are the physical properties of hydrogen peroxide. Now let us study the shape of hydrogen peroxide as a molecule. Here hydrogen peroxide is molecule. So now let us see the shape. It is a very important concept. Okay, here it is a non-planar structure. First thing we have to think is it is a non-planar structure. Second thing is molecular dimension in the gas phase and solid phase. It has got 2 structure. Okay, one it is in the gas phase and another one is in the solid phase. Okay, hydrogen peroxide we have taken and its bond length is 95 picometer and OO bond length is 147.5 picometer. Bond angle here is 94.8 degree and here outside OH means inside it will be one bond angle and outside will be another. So here outside is 111.5 degree. Okay, here now let us see in the solid phase. Solid phase here you see OH bond length is how much? 98.8 picometer and OO bond length is 145.8 picometer. And here bond angle also changed. In gas phase is very less, in solid phase it is more. Here how much? 101.9 degree. Here from the outer side's bond angle is 90 degree. But outer side's bond angle is very less when compared to hydrogen peroxide which is in the gaseous phase. It is 111. Okay. Next thing is chemical properties of hydrogen peroxide. Okay. Here it is act as a very good oxidizing agent as well as a reducing agent, both in acidic and basic medium. In both acidic and basic medium, it acts as oxidizing agent as well as a reducing agent. Okay. Next thing is oxidizing property. What are all oxidizing property it has got? Let us see. Okay. When hydrogen peroxide is treated with which one? Ferrous sulfate. If it is treated with ferrous sulfate, acidified ferrous sulfate, we will get ferric sulfate. We will get ferric sulfate. So, ferrous sulfate is treated with sulfuric acid in the presence of hydrogen peroxide. We will get ferric sulfate. Why I have said ferric? Because it is 3 is there. So, ferric sulfate and 2 molecules of water molecule. Okay. Next thing is hydrogen peroxide. When hydrogen peroxide is treated with which one? Lead sulfide. Hydrogen peroxide is treated with lead sulfide. We will get lead sulfate. We should know that. Okay. Next thing is it oxidizes too. Here, if hydrogen peroxide is treated with iron, if you got Fe2 plus ion, what we will get? It will be converted into Fe3 plus ion. Here, Mn4. If you take Mn4, manganese, Mn2 plus ion we have taken. For that, if you add hydrogen peroxide, we will get Mn4 plus ion. Again, it will lose the electrons. Okay, so it is a reducing agent here. Here, reducing agent. Here you see, already iron has lost 2 electrons. For that, you are adding hydrogen peroxide. If you add hydrogen peroxide now, what will happen? It has been converted into Fe3 plus. Again, it has lost 1 electron. Like that only in Mn2, manganese. Okay, its atomic number is 25. Correct, right? So, argon 3d5 4h2. Here, Mn2 plus means it has lost 2 electrons from s orbital. Now, if you add little amount of hydrogen peroxide to that, what will happen? Here, it has been converted into Mn4 plus. Again, it has lost 2 electrons. So, here hydrogen peroxide act as reducing agent in transition metals. Okay. Next thing is reducing property. Here, it reduces KMnO4. It reduces KMnO4 into manganese sulfate in acidic medium. We should know this. It reduces KMnO4 to manganese sulfate in acidic medium. So that KMnO4 is treated with hydrogen peroxide in the presence of sulfuric acid. So, we will get potassium sulfate, manganese sulfate and hydrogen peroxide. Okay, we should know this. It reduces always KMnO4 in the acidic medium to manganese sulfate. Okay. Next thing is it reduces iodine, I2 molecule to iodide in the basic medium. Here iodine, it is a molecule. For that, if you add hydrogen peroxide in the presence of hydroxyl ion, we will get iodide, 1 electron. Okay. Negative charge means iodide. I2 means iodine molecule. Okay. So, we will get iodide. Okay. Next thing is storage. How we can store the hydrogen peroxide molecule or hydrogen peroxide as a chemical, let us take. Okay. In a medical shop, we store it in a refrigerator. Always, it should not expose to the air. If it is exposed to air, what will happen? It will be converted into water molecule. Okay. So, always hydrogen peroxide is kept in a refrigerator in medical shops or in a laboratory. Okay. So, it can be catalyzed by dust particles. It can be catalyzed by dust particle, alkali metal surfaces. It can be stabilized by adding urea. If you add a little amount of urea to the hydrogen peroxide, it gets stable and it can be stored using plastic vessels in dark places, they have said. So, we should not keep hydrogen peroxide where sunlight is falling. So, we can keep it in a which one? Refrigerator only. It is a best place to preserve hydrogen peroxide. Okay. Next thing is uses of hydrogen peroxide. Where and all we can use this hydrogen peroxide? It is used as antiseptic to clean wounds, surgical instruments as well as for graggling. Okay. Next, in daily life, it is used as hair bleach for bleaching the hair and mild disinfectant. It is act as a mild disinfectant, as an antiseptic in solid, and it is marketed as perhydrol. It is act as an antiseptic. As antiseptic, it is sold in the market. It is sold in the market and it is marketed as perhydrol. In the medical shops, they will say it as dihydrol. Okay, and it is used in manufacture of some chemicals like sodium perborate and percarbonate, and it is used in high quality detergents. High quality detergents also hydrogen peroxide has been used. Next thing is, it is used in synthesis of hydroquinone, tartaric acid, and certain food products and pharmaceuticals. We should know this. Okay. Next, it is employed in industries. It is employed in industries as bleaching agent, for textiles, for bleaching some amount of clothes. We should use hydrogen peroxide. Clothes, paper pulp, leather, oils and fats. For oils and fats, we should use this. Okay, for bleaching purposes, hydrogen peroxide has been used. Okay. Next, nowadays it is also used in environmental chemistry, green chemistry also we will use this. Okay. For example, in pollution control treatment of domestic and industrial effluents, means some smokes has been liberated to the environment, right, from industries. There it has been used. Okay, to avoid all the largest amount of pollutants will be there in the smokes, right? So if you keep little amount of hydrogen peroxide there, where the smoke comes, it will absorb all the pollutants. Then little amount of smokes will be gone. So it has been used in green chemistry. Okay. Next thing is the physical properties of heavy water and its uses. Heavy water means always we should know that it is a deuterated water. Okay. So when ordinary water is electrolyzed, we can electrolyze this water and hydrogen is formed. Hydrogen is formed at cathode and oxygen is formed at anode. Hence, we will get deuterated water. Okay. Next thing is physical properties of heavy water. Okay. It has got high molecular mass than water molecule. Usually, water molecule, we know that we are for drinking purpose and all we will use, right? That is a local water, but deuterated water means we cannot use it for drinking purposes or any cleaning purposes. Just it is a electrolyzed water, so it has been used in some for inverters and all we can use. So deuterated waters means it will have high molecular weight than water molecule, and it has got low dielectric constant. It has got less dielectric constant. We should know this. Okay. Next thing is, it is used as moderator in nuclear reactors. It is used in preparation of deuterium, and it is preparation of deuterated compounds. So now let us study. Here you see calcium carbide. Calcium carbide is treated with deuterated oxygen. Okay. We will get C2D2, deuterated carbon. And next one you see sulfide. Sulfide is treated with heavy water. If you treat it with heavy water, what will happen? We will get sulfate. Next thing is aluminium carbide. Aluminium carbide is treated with heavy water. If you treat aluminium carbide with heavy water, what we will get? We will get carbonate and aluminium deuterated. Deuterated aluminium we will get. Okay. Deuterated means we should know that it is like isotopes. Okay. But we are preparing in a laboratories. Okay. So for heavy metals, we cannot expose these metals to the open environment. Okay. Next thing is dihydrogen as a fuel. If you use dihydrogen as a fuel, what are its properties? Let us study. Okay. Here it releases large quantity of heat. On combustion. During combustion, it produces largest amount of heat. We should know that. Next, on a mass basis, dihydrogen can release more energy than petrol. It releases more energy than petrol. Moreover, pollutants in the combustion, dihydrogen is less than the petrol. If you are comparing the pollutants with petrol, dihydrogen releases very less pollutants than petrol. Okay. The only pollutant will be oxidized is of dinitrogen due to presence of dinitrogen. Means we should know that only pollutant, which will be oxidizers of nitrogen. We have to take dinitrogen due to the presence of dinitrogen as an impurity with dihydrogen. Means that indicates that if you are taking today dihydrogen as for the combustion process, it releases largest amount of heat. When you take a dihydrogen for the combustion, it produces heat, we came to know. But when it produces heat, little amount of pollutants will be there, right? But here nitrogen, if nitrogen is present in that such place, means then little amount of pollutants will be released. Okay, that's all they have given. Next thing is hydrogen economy. If hydrogen economy, how it is, let us study. Okay, electricity cannot be stored to run automobiles. Electricity cannot be stored, correct, right? To run the automobiles, we cannot store it. Just we have to generate it, then only automobiles will run, correct, right? We cannot store it and keep. Okay, next, it is not possible to store and transport nuclear energy. We cannot transport nuclear energy. Just we can prepare on spot and we can release that, but we cannot store it, correct, right? So hydrogen is an alternative source of energy. It is an alternative source of energy, hence it is called as hydrogen economy. Okay, it has got some advantages as a fuel, which and all, available in abundance in combined form as water. On combustion, it produces water molecule, hence it is a pollution free. Next, H2O2 fuel cell gives more power. Hydrogen peroxide fuel cell produces more power. Next thing is excellent reducing agent. It is act as a excellent reducing agent. Okay, and therefore it can be used for substituted carbon for reduction process. For reduction process, we can use hydrogen fuel. Okay, these all about the hydrogen chapter. Thank you.